We will now classify organic compounds. Organic compounds, as we said, are hydrocarbons and their derivatives. Now, hydrocarbons will deal with separately, and when we look at the derivatives of hydrocarbons, we may have alcohols, we may have ethers, we may have aldehydes, we may have ketones, we may have carboxylic acids. So, like this we have a variety of compounds coming in the derivatives of hydrocarbons. In alcohols, we have this group which is characteristic of an alcohol, means all alcohols will have an OH group, a hydroxyl group. So, this is called the functional group, means any group that is present in a particular set of compounds common is called the functional group, and this is what decides the properties of alcohols. In ethers, we find that this group is common. For example, on either side we may have carbon. Here also we will have a carbon. So, we have a carbon, we have a carbon here, a carbon there. In aldehydes, we have a multiple bond, C double bond O and a hydrogen, and we may have a carbon or a hydrogen. Now, ketones will have C double bond O. On either side you will have a carbon. In carboxylic acids, we have C double bond O and an OH, and on this side we may have a carbon or a hydrogen. So, these are all, what shall we say, the common groups present in these compounds: alcohols, ethers, aldehydes, ketones, carboxylic acids. So, like that we have a variety of functional groups, or we have lots of derivatives of hydrocarbons, and these derivatives will have their own physical and chemical properties. Now, we will classify hydrocarbons further. Within hydrocarbons, we may have an open chain which is called acyclic, or a closed chain which is cyclic. Within acyclic, that is open chain, we may have a saturated type or an unsaturated type. Saturated means that only single bonds are present. In unsaturated, we may have multiple bonds. Then in cyclic, it may be either alicyclic or aromatic. Aromatic is a special kind of substances which have much different properties when compared to alicyclic. Now, in saturated, we said it is not having any multiple bond, it is only having single bonds. The general formula would be CnH2n plus 2. For example, suppose n is equal to 1. When n is 1, this will become CH4. CH4 is nothing but methane. So, methane comes under alkane. When you say alkane, ANE suggests that there is only single bond. Whereas, when it is unsaturated, the molecular formula is CnH2n. That is, the first alkene would have a double bond. Double bond should be between two carbons, because hydrogen cannot form a double bond. Therefore, the first alkene has two carbons. Now, so N has to be 2. So, C2H4, C2H4, that is ethene. So, ethene is the first alkene. So, when you have ENE, it suggests that there is one double bond. Similarly, when there is an YNE, it suggests that there is a triple bond. The molecular formula is CnH2n minus 2. Again, here you start with a 2 carbon system. 2 carbon system, because a multiple bond should exist between the carbons. So, C triple bond C with a hydrogen and a hydrogen would make it C2H2, that is C2H4 minus 2, that is 2. So, C2H2 is the first alkyne, C2H4 is the first alkene, whereas methane, that is CH4, is the first alkane. Alkanes can have just one carbon, but the alkenes and alkenes should start with minimum of 2 carbons. Now, in the case of alkene, that is ethene, we will put the formula something like this: C with a C having a multiple bond, that is a double bond, with a hydrogen here and a hydrogen here, a hydrogen there, and a hydrogen here, giving the molecular formula C2H4. Now look at the tetravalency of carbon. Each carbon should form 4 bonds. Here there is 1, 2, 3 and 4. Similarly for that carbon 1, 2, 3 and 4. So each carbon is going to have 4 bonds, that is each carbon is tetravalent. Now when it comes to this ethine, carbon has made 1 bond with hydrogen and 3 bonds to itself. So the number of bonds is 4, 1, 2, 3, 4. Similarly for this carbon 1, 2, 3 and 4. So tetravalency of carbon is found in all of its organic compounds. In these hydrocarbons we have seen unsaturated may have alkenes or alkynes, and alkenes and alkynes start with 2 carbons, whereas alkanes will start with only 1 carbon. Now when it comes to alicyclic, alicyclic means it should be a closed chain, but it is not aromatic. Means I can have, let us say, a carbon here and a carbon there closing itself to form a cyclic compound. Now at each carbon I should have 4 bonds. Already 2 bonds are existing. So the third bond and the fourth bond I put it to hydrogen. Similarly the third and fourth for this carbon to hydrogen. Also for this carbon. So this becomes cyclopropane. There are 3 carbons. To form a cyclic system we need a minimum of 3 carbons. We may also have 1, 2, 3, 4 atoms forming a closed chain, and at each carbon 2 bonds to hydrogen, which I am not showing, I am showing only the bonds here. So this is cyclobutane. So like this we have alicyclic compounds. Then when it comes to aromatic, aromatic substances, as we said, are having special properties, and the aromatic compound most commonly discussed is benzene, which will show like this. Benzene has 6 carbons. Benzene is C6H6, and in the molecular formula at each carbon there is only 1 hydrogen, because each carbon is also involved in a multiple bond. There is a double bond here, a double bond there and a double bond here, hydrogen at each carbon. Now look at the number of bonds that carbon forms. Each carbon is having 4 bonds, that is each carbon is tetravalent. So 1 here, 2, 3 and then 4 for this carbon. So like that for each carbon we have 4 bonds. Now this is benzene. We may also have another aromatic substance called toluene. Again like benzene, it will have hydrogen here, there, 5 hydrogens, and the 6th hydrogen is being replaced by a CH3 group. Now this is a double bond here, a double bond there and a double bond here. At each carbon again we will find that there are 4 bonds. This is toluene. We may also have a structure of this kind. This is going to be naphthalene. Again, to have tetravalency, at each carbon I will put a bond to hydrogen here, here, here. Now these are all hydrogens. This is naphthalene, that is the constituent of naphthalene balls, mothballs. This is naphthalene. So like that we have aromatic substances. Aromatic substances have got different behavior when compared to alicyclic. So these are all the different hydrocarbons that we have. Within hydrocarbons, as we said, there is also going to be a special feature called isomerism. Isomerism, I will repeat, is where a single molecular formula is going to give different compounds. Means there are more possibilities of getting compounds from a single molecular formula, and different compounds are going to have different physical and chemical properties. A few derivatives of aromatic hydrocarbons I have included here. Here we have the benzene ring. I am not showing the remaining hydrogens. There are 5 hydrogens here, 5 hydrogens at this ring, this ring, this ring, also in this ring, also in this ring and in that ring. Now this is called phenol, which is a constituent of phenyl and also Dettol. One of the phenols is a component of Dettol. Now this is aniline, that is an NH2 is attached to the benzene ring. Here we have hydrogens. So this is C6H5NH2. C6 C6H5OH. This is benzoic acid. C6H5COOH. This is benzaldehyde. C6H5CHO. This is acetophenone. C6H5COCH3. This is benzophenone. C6H5CO and another C6H5. So, like this we have a variety of compounds derived from aromatic hydrocarbons.